Yeah, I can hear you.
Oh, you can hear me. Okay, thank you so much. Yeah. Okay. Good morning, everyone. Today we actually gonna do most of what we want to do is gonna be on board. Um, we have two materials to cover today, and what I need from everyone, if you get stuck, please make sure you ask a question. Okay, the material I'm actually going to start with is the one that has to do, that is prepared for Tuesday, the one I call the probability on finite sample space. Okay, so we're going to start with that. And of course, I'm going to make use of my whiteboard. I'm also going to make use of the board. But let me first confirm, those of you that are online, I believe you can see my board, right? Those of you online, I need someone to confirm if you can see my board.
No, I couldn't see the board, whiteboard clearly.
Oh, okay. Oh, you can only see the whiteboard that I share, right? But you can't see the
I can
class
see.
Yeah,
board.
we can see the whiteboard.
Oh, you can see the whiteboard. Okay. 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 Now, I think I'm going to be going back and front. What I'm going to do, um, for those in class, I'm going to write on the board. And for those online, I'm basically going to be using the whiteboard. And I also believe those in class can also benefit from the whiteboard. Okay, so you know, we're going to continue from you know the Tuesday material. Okay, today we actually going to look at the set theory, then operation. Okay, operation between sets. Okay, so let's start with this material. Now, whatever I'm going to write today is very, very crucial. The moment you don't understand, please ask question. We're going to play a lot with notations. Now, I first want to start by having this. Okay, if I have something like this, for instance, S is a set. Okay, it's not necessarily a universal set. Okay, it could be a set on its own, and we got some elements X. Okay, so what this guy actually means is, S lies in that. Okay, for those of you, um, okay, for those of you online, okay, so what I'm trying to define right now, this guy is an element, okay, and this is a set. Okay, so all what I'm just trying to say is that S is contained, okay, in that. That is exactly what I mean. Like I said, we're going to be playing with notations. Okay, you need to be able to understand what I mean. If this is a class, if X, this guy is this class, this particular X could be member of the class. Yeah, go ahead. So which means the whiteboard should be preferred, right? Is that a general opinion? Like, since like what he's trying to say, what I'm projecting, since everybody can see that, okay, is that enough? Like, are you okay? Okay with that, right? Okay, but like I said, do not hide your feeling. I like satisfying everybody. Okay, thanks for that. Okay, now what I'm trying to say, in essence, is that let me see. I think a message came in. Let me see. Oh, okay. Okay, so now, like I said, you need to cite, example. Another way to write that, I can do this. Look at that. It's the same thing. Okay. So when you see something like that, okay, it means, okay, that particular X is inside S. Does that make sense? So we're talking about the same thing. But what if in a situation where I have this? Take a look at that. Okay, Y is not a member. That is what it means. Like somebody that is not a member of this class. Does that make sense now? That is what that notation. I told you the other time, we're going to be playing with notations. Or what I just need to know is, okay, what is the meaning? What are we talking about? We are sending a message. Now I'm going to do application now, since you understand, all of that. Okay, now if I now want to define my set as this, we have several ways of defining sets. We could use a listing method. We could use a property method. This is a property method. The property method is more or less like, the shortest way of describing set. Now, we know what that guy is trying to tell me now. Okay, X such that X lying between 3 and 4. You remember the other time I walked you through the interval, right? Open interval. This is an open interval now. Okay, so what this is trying to tell the world is S is greater than 3, but it's less than 4. Automatically, that X can never be a natural number. Does that make sense? Now, if I write this and I write this, okay, and I write this, I want you to look at the first one, pi. Is pi a member? Of course, because pi is 3.14 something, okay, and 3.14 something lies between 3 and 4. Therefore, this guy is right. What about the other one? The second one is trying to say 3.5 is inside. Is 3.5 inside? Yes. 3.5 is between 3 and 4. Now, let's take a look at the third one now. The third one. You know what third one is talking about? It said 5 is not in. Is that true? Okay, 5 is not in because we're talking about X lie between 3 and 4. Any question? Go ahead. Oh, whether it's going to be capitalized? No. You don't capitalize it. It's going to be a lower case because it's a member. Okay, the whole body is going to be capitalized. Okay, why a member? Just like you are talking about difference between a random variable and a realized value. That's a good question. Okay, now we are done with that. Now I want to quickly move to subsets. Since you understand that, okay, I want to move to subset. Now, when I'm talking about, a subset, we're going to use a different notation. Okay, now for instance, if I write something like this, okay, S is a set, T is also a set, but you know what? S, okay, is a subset of T. Now, if I want to say that is a subset of T, another way I can write that, I can do it this way. Okay, so what that means is that T is, okay, a superset of X. Okay, why when I say T is a superset of X, is another way is S is a subset of T. If I call somebody my boss, right? What do you expect my boss to call me? My boss is not going to call me a boss. You get what I mean, right? So that is what it means. Okay. So any question on what I just displayed? Like I said, we play with notation a lot. It's not as if math is difficult. It's not as if statistics is difficult. You know why we're going to do a lot of maths in this course? Because it is called theory of statistics. Okay, theory of statistics requires, mathematical knowledge. And of course, in mathematics, we play with notations a lot. And that's why I want to walk you. Let me tell you, the moment you understand notations, you'll be able to understand equations, you'll be able to understand models. Okay? So please, if you don't understand, please let me know. Now, another thing I want you to know is take a look at this guy. You know what he's telling me? An empty set is a subset of any set. I'm going to give you an example. Before you came into this class, the first person that came into the class met the class empty. Therefore, that emptiness is a member of this class. Does that make sense to you now? That's what it means. Okay? So please take note of that. That phi is an empty set. Okay, that's a notation. Okay, for that. And let me also tell you this. Take a look at this property. A set is a subset of itself. Minnesota is a subset of Minnesota. Does that make sense to you now? Okay? We have a way to prove all this. By the time you see assignment on Sunday, oh, by the way, you can check the syllabus. I included assignment due date now, the chapters you're going to cover in the textbook. Okay? Okay. Now, if that is taken, the next thing I want to talk about, I'm still on the subset. Okay? If this guy belongs to this guy, okay, and this guy belongs to this guy, okay, then x equal to t. Now let me tell you this. If I call my boss, and my boss also call me his boss, then we're equal. Does that make sense? That is what it's trying to say. If x is a subset of t and t is a subset of x, then we got equal set. What do I mean by equal set? Equal set means they got the same element in them. And I want to believe that is a philosophy shared by friends. Before we can be friends, we believe we're equal. Does that make sense to you now? Okay. Any question on that? Okay. Now you understand that now. Okay. Another thing I'm gonna say is this. Okay. If we have x belonging to this and t, okay, is not a subset of x, then the two sets are not equal. Okay, similarly, just take note of that. Okay, now I quickly want to go to universal set. In this class, we're actually adopting a notation for universal set, okay, which is basically this guy. Okay, when you see that notation, omega, that's a universal set. Okay, now if I write this and I write this, okay, we got two sets, set x and set t, and they are subsets of the universal. For instance, I'm basically going to call the universal set here United States. And I'm actually going to call a set S, maybe state of Minnesota, and set T, maybe state of Michigan. Okay, the set T and the set S, they have elements. Minnesota have people, Michigan has people, Michigan, it belongs to the United States, Minnesota belongs to the United States. Does that make sense? You know, wait, okay, go ahead. Yeah, when you're talking about, you know, if you look at the word universe, you're talking about everything that contain all the elements in this world that you can think about. That's what it means. Does that make sense? So if I view United States as a universe, right, then United States has a components in terms of states, and those states also has elements, and that is why I'm not using X. X is just a member. Remember, X is not a set, a member in a set. Does that make sense? So which mean X, this particular member could be from this guy, or it could be from C. Does that make sense now? Okay, so have I answered your question? Okay. Now, the next thing, now since you understand the universal set, you understand the subset, then I want to go into a power of a set. Okay? Please, if you don't understand. Oh, go ahead. Yeah, it's omega. This guy here, yeah, omega. Yeah, yeah, it's omega. Okay, now the next thing I want to talk about is power of a set. Okay, the power of a set. You know, the power of a set is just going to tell us what is a possible number of subsets we can have in a set. Possible number of subsets we can have in a set. Okay, now I'm basically going to give you an example now. If I have a set X, okay, it has this element. Let me tell you this. When we're talking about sets, the element in the set could be numbers, could be alphabet. Does that make sense? Right now, we're under in that particular set, we got X, Y, and Z. Okay, they actually have three numbers. And what I want to figure out is what is the power of this set. Now, we got a notation, okay, for the power. Take a look at that. You know, what do I want to find? The power of a set X, okay? The power of a set S, if I basically want to know what is a possible number of subsets we can have here, we got a formula that we're going to use. And I'm going to show you right away. Okay, it is 2 raised to power cardinality of the set. Okay, now when you take a look at this, we call that cardinality, or you know, cardinality. Okay, cardinality, okay, of a set. The cardinality of a set is just the numbers of elements in a set. How many elements do we have in that set? We got 3, right? Okay, the cardinality equal to 3. Then if I now want to find the power of a set right now, it's going to be 2 raised to power 3. And what is 2 raised to power 3? That will be 8. Now, you know what this guy is trying to tell me now? We're basically going to have the 8 number of possible subsets in this particular set, which I'm actually going to write right now. Any question about how I figure out the cardinality and the power of a set? Any question? Those of you online, can you confirm if you are still hearing me clearly? Those of you online, I need someone to confirm if you're still hearing me clearly.
Yes.
Oh, thank you so much. Thanks for confirming that. Okay, now we know the possibility now, right? Oh, this is it. I've seen a lot of assignment question here today. Please watch out. If you don't understand, ask a question. Now we know the possible number of subset we're going to have here. It's going to be 8. Now, what are these elements? Now we're going to see now. Okay, we know it's going to be 8. Okay, so what we're going to do is I want to write that cardinality or the power now. Okay, that particular power now. Okay, we can have X, Y, Z. Okay, when they appear singly, then when they appear in twos, okay, X, Y, okay, Y, Z, X, Z, X, Y, Z. Oh my God. How many do I have now? 1, 2, 3, 4, 5, 6, 7. Can somebody remind me of the 8th one? Yeah. The empty set. Now send me a message for extra credit. 1 point. Okay. I saw you raising up your hand. Is that what you wanted to say too? Send me a message. I can read your mind. Send me a message for extra credit. Okay. Empty set. How many? I got 8 now. Take a look at that. Okay. Now, in assignment, when I ask you what is the possible number of subset, okay, you tell me, oh, 2 raised to power the cardinality. Then you will also need to list them. This is listing them. Does that make sense to everyone? Okay. Now that is what we call the power of a set. Now, the next thing we want to talk about now, I want to go into the operation between sets. Okay. Talking about operation between sets, of course, uh, we cannot live in this world in isolation. We need one another. Okay, which means we establish relationship. Minnesota established relationship with Wisconsin and so on like that. Relationship occur between countries. We're also going to have relationship between sets. Okay, now we have a set A, set T. What kind of relationship they're gonna have together? At this moment, I'm going to walk you through what I call union. Okay, intersection, the complement, and so on like that. But if we want to study relationship between sets, we're basically going to make use of what I call Venn diagram. Okay, Venn diagrams. Okay, that's what we're going to, the Venn diagram is basically going to look like this. The rectangular shape that you see is basically talking about the universal. Does that make sense now? And having this guy now, take a look at what I'm drawing now. Okay, if I put the omega here, the omega is the whole territory. Okay, talking about, okay, all right. Can you say that again? Oh, I'm sorry about that. When I'm teaching, I'm assuming students are on the same level. So I understand what you mean. So I have to go through. That is my style of teaching. I know some of you already have the understanding of some of this, but your understanding for now doesn't matter to me because I'm putting everybody on the same level. Does that make sense to you now? So the way I'm going to describe it, I'm going to start like explaining it one after the other like that. I know you understand it. You get what I mean? Oh, is that not what you mean? You need something like working fast, right? Yeah, but I'm going to tell you, slow and steady, we win the race. Here because theory of statistics involve you understanding some basic fundamentals. You're going to get to a point that you're going to see a lot of complicated, but for you to be able to understand the complicated situation, I need to first go through what I'm walking you through now. Does that make sense to you now? Okay. Let me get your point. What are you driving at? Yeah. Yeah. Yeah, I understand what you're saying. I will not assume that. You know why I will not assume that? They put it in my syllabus. And it doesn't matter whether somebody have done it in first grade, second grade, or whatever. I'm not interested because it is in my syllabus. And if you look at this class now, there are some students who have maybe um, graduated from high school some years back and they just come back to the college. So we assume you're going to see what we're doing. So I understand what you're trying to say. That universal, I understand that, but I think that is the way I teach because it's in my syllabus. I will work my student, even if it is simple. That is what I do. Does that make sense? Hope I didn't offend you. Hope I didn't offend you. Oh, okay. Okay. Now, uh, then another thing is when I'm explaining this, even though you understand it before, then you will be able to confirm and consolidate on what you understand. Because we're going to get to a point that I will be writing some equation on the board. It may be difficult. You know why it may be difficult? Because of the fact that we did not review some basic fundamentals. You're gonna see at the end of the day. Okay, now we take a look at what I have now. We have omega is everything, and if I have this, if I have this, now what this guy is trying to say, that very T is in S, okay, and S is in the universal, okay. What I need you to see, that very T may be like this university. This university is inside state of Minnesota. The state of Minnesota is inside United States. That is information I'm passing across. Does that make sense? I told you, if you want to understand this, we relate this to real life. Then you will understand that. Now, so what I'm trying to say in essence is that from this picture, that is what you can see. Okay, that belongs to that, and the whole thing belong to the omega. Now, the next thing that I want to go talk about is the complement. Now, when I talk about complement, okay, now when I'm considering a set X, okay, and the complement of set S, okay, is just every other element, okay, outside that particular set I'm talking about that is in the universal. Okay, now this is what I mean. Okay, X actually here, okay, X does not. Okay, now when I'm giving you assignment, I need you to be able to state those definitions for me. Yeah, go ahead. Yeah, because when you see the first assignment, you'll be given some set. I'm going to ask about the subset, power of a set, intersection, union. I'm going to ask about Cartesian products. I'm going to ask about a lot of stuff. And that is the reason why from today, I'm actually going to be using this because I want to explain them. Does that make sense? I'm not just going to be projecting lecture slide. This is a theory of statistics. The theory of statistics need to be analyzed, like, walk student through. You understand what I mean? Okay. So now I want to talk about the complement of a set. This is the definition mathematically. If I ask you in this class, what is the complement of a set X? I have X is a set. What is the complement of that particular set X? If that set S is this class, then the complement of this class, there are other students in the University of Minnesota. Does that make sense to you now? That is what this guy is trying to say. Okay, S does not belong to this class. Who does not belong to this class? Other students in this university. Does that make sense to you now? Okay, like I said, when you relate notations to real life, they are super easy. Okay, now what I'm now trying to talk about in that situation is just like, you also need to take note of this. We have a universal set. What is the complement of universal set? That would be empty. Does that make sense? Okay. Similarly, what would be the, okay, go ahead. Can universal set be what? Exactly. Exactly. No, this is what happened. You ask whether the universal set contain empty set, right? Okay, this is the deal. There are situations where we are cautioned about empty set. Now, the situation is more or less like when I'm talking about the universal set, and I want to talk about the complement of universal set, then we're going to say X where. Like for this time, when I'm talking about X, it is not only X that we have when talking about planets. You get what I mean now? Okay, so the empty that I'm talking about is more or less like the example I used the other time. Before you come to this class, the first person that came in met this class empty, right? Now, if you make the class empty, when students are now around, okay, and you only have empty, now it means the complement of the emptiness is is you that you are around now, okay? And what is the complement of you now? It's going to be the empty. That is exactly what I mean. So in your question on whether the universal set contain empty, okay, that can be argued about. But this is my perception about it. Okay, before you come into a place, you meet a place empty. Okay, which means you are not in there, you are in there. So that's exactly what I mean. Okay, but by the time we use examples, you're basically going to confirm, some of the things that I just talked about. Okay, now because of that, I'm actually going to say this. We have a lot of assignment question here. In the assignment, we're gonna give you some, figures, letters that you're gonna work on. All we just need to do is to prove all this. If you take a look at the first one, it's talking about the complement of the emptiness. The complement of the emptiness is the universal set. The reason why I said the question you asked about whether universal set containing emptiness is because if you want to go, that is controversial. If you want to go by science, they're going to tell you the word was without form before, right? And later the word became shape. So if you take a look at the first one, it's trying to say the complement of the emptiness is the universal set. Then the second one is now saying the complement of the universal set is the emptiness. Okay, I just wanted to take it for, so which means the understanding now is universal set does not contain emptiness. Because if the universal set contain emptiness, this is a violation. Let me tell you this. In statistics, mathematics, we base whatever we do on this. This is what I write? Assumptions. Assumptions. Does that make sense now? Okay. Yeah, go ahead. Yeah, that is on the assumption now. On the assumption. That's what I mean. Okay. Now, if I have a set S and I have the complement of that, and I take the complement of the complement, then it will return that to the original set. That is the third one. Does that make sense? The complement of the complement. So just take note of that. Okay. Now, the next thing that I need you to pay more attention to is a relative complement. Relative complement. Okay, take a look at this. Now, I want to talk about relative complement now. I got two sets. I'm trying to say X belongs to T, but X does not come from X. Mathematically speaking, it is the same thing as T minus X. Let me tell you, math is not difficult. But the issue is students don't get familiar with the fundamentals. What we're doing now will be helpful to you on the long run. You're going to see. Now, if I ask about relative complement, I need this definition from you. Now, based on this now, I can ask you in exam to draw the Venn diagram associated with this. Okay, please take notes. Now, I got something like this now, and I have this, and I have this, right? And I have this. And I shade the T part. I shade only the T part. You know what that means? That is T only. T only. Because S extend the whole up to the middle. There's a difference between having T as a whole and having T only. This is the relative or complement. Now, let me tell you this. I will apply this in politics now. A deal, a debt limit deal was struck in in both House and the Senate, and that was signed by President Biden recently. Let's say X is the total number of Democrats and T Republican. Now, the T only here maybe the numbers of Republicans that support the deal. If you follow the politics in the United States, okay, we got some Republican that did not support the deal. We got some Democrat that did not support the deal. You know, let me tell you this. Why am I doing this? If you are doing math without applying it, it's an exercise in futility. What is the essence? Math is to be done, is to be applied in society. Go ahead. You say what? When I'm talking about the word mutually exclusive, you need to for define the context. You know what I'm trying to say here? The T that I shaded is representing the number of Republicans that support the deal. If I shade the whole thing is Republican. And that's why you need to give your interpretation. You need to give your, what is it? What I mean, you know, you need to tell the world. You know, you need to define what you are doing. Does that make sense? Okay. Now, take a look at that. Now, the next thing that I'm actually going to talk about now is going into union. But before going into union, I'll first trying to, you know, okay, let me be going one by one. I want to go into union now. I want to go into union. Please don't forget, union. If I ask you a question in exam, I need this definition. This definition is very, very important. This is a union. X. X is a member of a set X, or is a member of a set T. Okay? Or is a member of both. You know, example of this? These two guys, they live together. They organize an house party. This guy invite a set of friends. This guy also invite a set of friends. What happened in the party? You have a combined set of friends. There's possibility that some friends here may know some here. You're talking about union. Which is this? Please draw. Make sure you draw. Okay? Make sure you draw. The whole thing is universal said, right? Take a look at this. Does that make sense to you? The universal set is a combination of the union and the one outside it. The one outside it is a complement of X union T. I want to believe the whole world did not come to the party. Okay, others that did not that were not invited is the X union T complement. Okay, now we now want to talk about the properties of union. In the properties of union, okay, union is commutative. In the sense, is that agree, right? It's commutative, we can prove that. S union T is T union X. And it is also associative. Okay, for instance, this would be equal to this. Every time you hear association, the number of sets must be more than 2. association. Two people can do association. Two sets cannot be into associative. Association start from 3. So take a look at that. Or that can actually be proved. Now, take a look at this. S union days. I want to award an extra credit. Can somebody tell me? S is yeah. Omega. Good job. Send me a message for an extra credit. Minnesota Union United States. What is it going to give? United States. If you can relate your math, you will understand your math. Let me tell you this. I derived 200 equations when I was doing my PhD in Africa. And that gave me a scholarship to present my work from Africa. I got invitation to University of Oxford in the United Kingdom. Don't cram your math. Understand your math. Relate your math. I don't understand math if I cannot explain to my grandma. My grandma doesn't go to school. If I can explain my math to my grandma and she understand, then anybody in the world will understand. Okay, now we're moving gradually to a complicated situation. Take a look at this. X1 union X2 union X3, okay, blah, 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 union Xn, okay. I'm actually going to write it in a short form using that. Because we can have a situation where we got so many sets and we're looking at the union of all of that. Instead of, in order to save your time, you can just write that in short form. Does that make sense? Okay. Please take note. We're going to play with notation a lot in this course. We're supposed to stop at 9:55, right? Okay. Now, I'm going to interception now. What we're going to do today and tomorrow, we're focusing on those materials, and I'm going to walk you through a lot of exercise. Because your assignment, number 1, we focus on all of that. Now, I want to talk about interception now. Interception now. Okay. What is the definition? Please look at the way I'm actually putting the definition now. I remember the other time when I was talking about union, what you see in the middle was or. Right now, intersection is and. S belong to S and S belong to T. And if I basically want to draw the Venn diagram, okay, and I have this. If you take a look at the one in the middle, is the point that is very common to the two. If I want to talk about the deal that I talked about the other time, using another example, maybe the number, that is where Democrats and the Republican agree. Where they don't agree is another thing we're going to do that we call symmetric difference. You know where they don't agree? They don't agree where that is not shaded. They don't agree here, they don't agree here. The one in the middle is bipartisan. Bipartisan. Okay. When we talk about properties now, interception is commutative and it's associative. I can ask you in test. Today, we've talked about union, right? Union is commutative and associative. This guy also is that. What do I mean? When I said it's commutative, okay, commutative means if I can show that this equal to this. In the assignment, I'm actually going to give you, maybe I'm going to write this, something like that. and you're going to have this, whatever, like that. Maybe that will be given to you and ask you to prove the commutativity of intersection. The moment S intersection T equal to T intersection S, you have proved the commutativity. And that commutativity hold all the time. Now, the same thing with the associative. I've seen a lot of assignment here today. A lot of questions in the assignment. Take a look at this. You see that, right? It means I'm going to give you 3 different sets. Then I'm going to ask you to prove the associativity property of intersection. All what you need to do for me is to verify that using the set, using the example given to you. Does that make sense to everybody? Okay. Now, I'm going to go into generalization for interception now. The same thing I did the other time to union, where I'm going to have this, 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 this. Instead of having that, I can just write. Do you know that very guy is the shortest way to write what you see? Look at that. Like I said, we're going to play with a lot of notation. Okay? We're going to play with a lot of notation. Now, in the situation, lastly for today, well, we're going to continue from that tomorrow. If I have this equal to that, do you know I can give you this equation and say prove that for me? There's so many ways you can prove that. You know what you're telling the world? S and T are mutually exclusive. Mutually exclusive means they are disjoint. They cannot occur together. By terms of Venn diagram, you're basically going to have this guy. They don't come together. Like I said, I'm going to continue from. Let me prepare your mind before you go. This course is called Theory of Statistics. I don't lecture, I teach, I tutor. And you're going to see the evidence from what we're going to be doing from now. A Theory of Statistics course should be, it should be something that you do on board, not something you'll be presenting. No, you explain that. Because these are the fundamental principles of statistics. And all what I just need from you is to ask questions when you get stuck. So before I go, I want to appreciate those who have been asking questions, and I will advise that you continue asking your question because you're going to gain from it and others will gain from it as well. Is there any question before I go? Like I said, if you check the syllabus now, I've put the deadline for submission of assignment. The first assignment will be uploaded on Sunday, this very Sunday, and the deadline for submission will be the following Sunday. And in that particular textbook, I think we're doing like 5 to 6 chapters, which I've already listed in the syllabus. You can check. Okay. So please make sure you actually attend class, because what we're going to be doing from now, okay, I want us to do it together. We are going to participate together. Make sure you stay safe and have a lovely day. Bye for now, everyone.
Thank you.
You're welcome. This of you all, any question? Oh, thank you too.
No question, thanks.
Bye.
Oh, so you can see what I presented clearly, right?
Yeah.
Oh, I'm so excited to hear that. Okay. Now I have my iPad around, and that is the way we're going to be doing it. Okay. Make sure you stay safe. Bye, everyone.
Bye.
Yeah, bye. Yep.